All right, it is advisable that you watch the last video because this is just a continuation of the differentiation rules. So we'd already covered this one in the last video. Let's look at the next one, which is the product rule. We have two functions which are multiplying each other. We have maybe 2x multiplied by 3x, although that one is you can multiply simply and then integrate, differentiate. But there are some serious situations where it doesn't make sense to multiply. Let us see what you will do. Y is equal to u multiplied by v. Then u is a function, v is also a function. How do you do it? First, you say one function stays the same, you multiply it by the differential of the next function plus, then the other function is tend to stay the same, then you differentiate the other function like this. U stayed the same. Remember, u is f of x. U here stayed the same, and then we integrated, we differentiated v. Then we added v, now is staying the same, and then we differentiate u. It's as simple as that. You just apply this rule, then you get your desired results. Let us see if we can look at one or two examples. All right. This one at the top is just a repetition of what we've already seen. All right, as I was saying, in this case, it is very difficult, or it is time consuming to multiply x plus 2 and this x squared plus bx. It's very time consuming and difficult at the same time. So what do we do? This one is our y. The whole function is y. This one here is our u. This one is our v. Remember, I said v prime is a simply differentiation of v. So what have you done here? This is u, and this is v prime. If you have seen the past video, you know now how to differentiate x, how to differentiate 2, how to. So this is the first part. Then we add now this v. Here we had v prime. Now we simply have v. But you might be asking yourself, where is u prime? U prime is equal to 1 from the past video. U prime becomes 1 because the differential of 2 is 0, the differential of x is 1. So we are only left with this one. So as you can see, the product rule is very, very useful. Let us look at the second example. Again, this is u, this is v. Then what do we have? This is u again. This time we started by the same thing which we did the last time. V prime plus, now it's a v tend to stay the same, plus u prime. This is exactly how you do your product integration. Let us continue with our, what do we call them? Our rules. Now we have the quotient rule. The quotient rule, again, we use u and v. So the sixth rule is one function divided by another, like this, where u and v are functions of x. We've already seen this. So straight from the book, the differential of this one is v. Remember, v is a function and u is a function. V, then integrate a differentiation of u as a function minus u differentiation of v as a function all over v squared. Here, what I can say is it is important to note that v is our denominator and u is our numerator. So you shouldn't make a mistake of thinking that it doesn't matter who starts here. You're thinking about maybe starting a u here or putting a v here. It matters. The formula is like this: the denominator here, numerator here, then the denominator here, just like that. All right, let's see if we can get one or two examples where we can apply our formula. All right, this one will do. The top one is just the repetition of the formula. This one will do. So this is our u over this one is our v. So we said denominator first, v u prime is du dx. So just put u prime here minus u v prime, again it's 1 here, it's indicated as a 1, which is good, all over v squared. Then simplifying this, we ended up with this one. This is a good example of a quotient rule. All right, let us continue. Then number 7 is the chain rule. The chain rule, how do we apply the chain rule, and where is it necessary to apply the chain rule? Here, let's see. If y is a function of v and v is a function of x, then y is a function of x. All right, this is simple English, we understand it. But thinking of it as a multiplication and division, let's see what we can do here. Here you see we have dy dx is equal to dy dv multiplied by dv dx. There's a very big chance that you might just think of it as cancelling this one, and it will just bring you back to your original dy dx. But this one is better explained with examples. Let us see what we have next. We have an example here. Y is equal to ax squared plus bx to the power half. Right, here as you can see, the rules we have studied, yet they cover either this or just this, this half. They don't cover both. So what do? We replace this one with a v, with a constant, another constant, maybe u. We can replace this one with a u. Right. Having replaced this one with a v, means that y is now since this one is now v to the power half, then we try to find a dy dv also. Which is, as we agreed, we bring the 1/2 here, 1/2, v to the power half minus 1 is minus half. That's dy dv. Then here we have v and x. This is dy dv. Now what do we need? dv dx. dv dx is simple differentiation. We differentiate this and then we differentiate this. Then the final answer, this is dv dx. The one here is dv dx. This one, it's dv dx. So we have applied our rule successfully. dy dx is equal to dy dv. Remember, of course we will remove the v here. dy dv multiplied by dv dx, because v is ax squared plus bx, so we just remove v and put ax squared plus bx. I'm sure that is understood. All right, we continue to item 2. It's the same situation as the previous one. I will leave this one as a homework for you guys, but it's pretty simple. You just apply the same things, except this one is now simpler since it doesn't involve any fractions. 4 minus 1 is just 3. All right, let us look at other rules. We have the inverse function rule. If x is equal to f of y, then dy dx is equal to 1/dx dy. And this one you can just apply it as it is written here. All right, let's see. Maybe this is a little interesting than I thought. Right, x is equal to 3y squared. The x dy is 6y. This is correct. Then dy dx is 1/. It's as simple as that. No, it's not as interesting as I thought. It's actually quite simple. Right, let us see. What do we have here? Here we have y is equal to 4x cubed. Dy dx, then dx dy is okay. So it's quite straightforward. All right, let us look for another rule, which is the exponential. Differentiating the exponential. When we differentiate ex, okay, let us see this one in another video. Please kindly subscribe to our channel, because we're going to keep posting more and more and more videos. The next video we are going to continue from this page.